Let's make a scatter plot. We'll visualize the famed iris dataset. This is a quite famous dataset from R.A. Fisher, published originally in 1936. It's about iris flowers. Versicolor, setosa, and virginica are three different species of iris flower. The petal and the sepal are these two different parts of the flower. This illustration, by the way, is from this piece by Carlin Willems. Let's take a look at the iris dataset available in CSV format. We have quantitative attributes for the length and width of the sepal and the petal. We've got one categorical attribute for the species. There are 150 rows in this dataset. Each one represents a single iris flower. The question I'd like to answer here is, what are the relationships between sepal length, sepal width, petal width, and species? Could some combination of these measurements possibly predict what the species is? Questions like, is there a correlation between this and that, or what's the relationship between this and that, are often best addressed by scatter plots. To get started making a scatter plot, I'm going to fork this stylized bar chart. Next, I'll change it to load in this other dataset, the iris dataset. I'll delete that URL there that loads in the United Nations data and replace it with the raw URL for the iris dataset. So I'll copy that and paste it in here. Now we've got some outdated logic, like this logic around population and this logic that only takes the first 10 entries. We no longer want to take the first 10 entries, so I'm just going to delete that code there. And this function here, since it just takes a single argument, data, and invokes the function setData and passing that in, we can just replace that with setData. Now this logic around parsing our population from a string into a number and multiplying it by 1,000 is outdated. Since a lot of our values here are numbers, we should take care to parse them from strings into numbers before we make the visualization. These four attributes are the ones we need to parse into numbers. So I'll copy that list. I'll get rid of this logic related to population and then paste that list. To parse, for example, sepal length from a string into a number, we can say d.sepal length equals d.sepal length. And we need to parse this from a string to a number, and for that we can use unary plus. And we can do the same for sepal width, petal length, and petal width. All right, now that we've parsed these strings into numbers, we're ready to visualize. Let's take a look at index.js. For a scatter plot, we don't need arc, pi, or scale band, so I'm going to delete those. In a scatter plot, x and y are both linear scales. Let's take a look at the code that sets up our scales. First of all, we need to decide what x and y are going to be. For some reason, I just like x to come before y. I don't know why, it's kind of a silly thing. But I'll just rearrange the code so that x comes first. X and y should be quantitative attributes. Any of these. For x and y, let's just start with x is sepal length and y is sepal width. Now that we've got our value accessors set up, let's make sure that this scale generation logic is correct. While bar charts need to have a zero baseline, it doesn't really make sense for scatter plots. Scatter plots typically go from the min of the data to the max. Just like max, there's a function from D3 called min, where you can pass in the data and an accessor function. Let's pass an x value. Since computing between the min and max is such a common thing, there's actually a utility provided by D3 that will give you this array. It's called extent. So instead of saying min and max, we can just use extent like this. To use extent, we need to import it from D3 right here. All right, we've imported extent. Now let's take a look at the Y scale. Here's Y scale from the bar chart, which is a band scale. For a scatter plot, though, this really should be a linear scale. The domain should not be each unique value for Y, but rather should be the extent of the Y value. So I'm going to get rid of this data.map call and take this extent expression from our X scale and just replace X with Y. Also, padding inner doesn't really make sense for linear scales. All right, we've got our X and Y scales set up. Now let's turn to our marks. Where do we render our marks? Oh yeah, it's in a different component called marks.js. All right, here we go. For each rectangle, we instead want to make circles of a scatter plot. So I'll just change rect to circle. And circles don't accept X and Y, but they do accept CX and CY, the center X and Y position. Circles also don't accept width and height, but they do accept the radius, just called R. I'll set the radius to, say, 10 for now. The key, I don't think it should be the Y value of D because multiple rows could resolve to the same Y value. So I think I'll just remove that key. I think if you don't specify the key, React uses the index in the array. Finally, CX should not be 0, but rather should be the X scale of the X value of D. I'll just replace these Y's with X's. This should be working. Let's see if there are any errors in the console. yscale.bandwidth is not a function in axis left. Let's take a look at axis left. Yeah, for setting the Y position of the text, we needed to use the scale bandwidth to center it, but since we're not using a band scale anymore, that doesn't make any sense. All right, check it out. We got something to show up for our scatter plot. The Y-axis is not quite right, though. See, we're using the yscale.domain, but since this is a linear scale, now we can go back to using ticks. All right, now we've got our tick marks back. I would like to make the Y-axis a grid with these grid lines, just like the X-axis. So we can take this logic around creating a line for each tick from axis bottom and implement it in axis left. I'll just paste that right there. And instead of setting Y2, we should really set X2 to inner width. This code does not have access to inner width, though, so we need to add it here as a prop. And then when we invoke axis left in our index.js, we need to pass in inner width equals inner width from this scope. Okay, we're passing in inner width, and we see a line go all the way across, but I think something is still missing in our axis left. Oh yeah, we're not setting the Y position for our lines. We could go about setting Y1 and Y2 to the same value that we're using here for the Y position of our text. But a better way to do it, since our line and our text are both within the same group element, is to just set up a transform on our group element to translate by 0 in the X direction and in the Y direction, translate by Y scale of tick value. So I'll cut that logic from there and paste it into here, and then get rid of this leftover junk. All right, now we've got a grid of lines. All right, this is progress. But just by looking at this visualization, we have no idea what the y-axis means. And the x-axis still says population, so we need to address those things. Let me first make it so that instead of saying population, it says sepal width or whatever that actually is. I think that label is defined in index.js. Yeah, scrolling down, we see here is that text label that says population. But honestly, I don't even remember what this is, and I want to be able to tweak this when I tweak the x-value accessor. So I'm going to make this into a variable called x-axis label. And the value of x-axis label can be defined right here. Const x-axis label equals, and now I can see what it should be matching. We can say sepal length, but we can clean this up for human consumption. Sepal length uppercase with a space. All right, now it says sepal length on the bottom. Looks good, but I'd also like to put a label on the side for the y-axis. In addition to defining x-axis label, why don't we also define y-axis label? And the value of that should be sepal width. And I think I'll add some white space just to differentiate. This is the x section, and this is the y section. Now we need to add a similar text label to our x-axis label, which is right here, for the y-axis. So what I'll do is I'll copy this logic, and then I'll paste it right here, and then change the text to be y-axis label. Now we've got it there, but it's overlapping with our x-axis label. So we need to change x and y to position it on the side in this space right here. We pretty much need to swap x and y. And then change height to width, or no, actually x should start at 0, and then we will have some y-axis label offset, and that should be the distance from the axis in this direction going to the left. Therefore, this should be minus y-axis label offset, and we don't have that defined right now. Let me go and define that. Here's our x-axis label offset, and let me just make something similar called y-axis label offset. All right, going back to our text, x is now minus y-axis label offset, and then what should y be? It should be inner height divided by 2 to put it in the center vertically. And then I'd like this text to be rotated. To rotate text, we can set a transform to be rotate, let's say 90 degrees. That did rotate it, but it's going downwards, and also the position is off. To get the text to read upwards, I think we can use minus 90 degrees here. All right, that's the correct rotation, but now the position is off. That's because this rotation, I think, is with respect to the origin, and because it's inside of this group element, the origin is right here. And we can sort of test that theory by looking at different rotations and see around which point is this thing rotating. It kind of looks like it's rotating around this point here. So to solve this problem, instead of specifying x and y, we can put x and y in our transform by using translate by x and y. Then I'll just clean up these to use ES6 string template literal notation. So we translate by minus axis label offset in the x direction, and then in the y direction, inner height divided by 2. And then we need to close out that backtick and the brace. Okay, we still have the same problem. What if the translate comes first before the rotate? All right, that worked. See that? Sepal width is right there where we want it to be. All right, that's pretty much exactly what I wanted to do here. Now we can just make some minor tweaks, like there's a lot of white space on the edge. So I'll just tweak the left margin. 200, 100, looks pretty decent. And it's a bit far from the axis, so we can tweak y-axis label offset. Say 40, that looks decent. And then we can bring down the left margin just a bit more. All right, we've created this scatter plot. One thing I notice here is that this circle goes on top of this tick label. Before moving on, I'd like to solve that particular problem. One way to solve that is to make sure that the marks get rendered behind the tick labels. And with SVG, the Z index, meaning front to back ordering, is the same as the ordering in the document. So right now these marks come last. That means they come on top of everything else. And we can move them behind everything else by putting them first in the document. Now, see what happens? They're behind our grid lines, which is an unanticipated consequence. But now that label of 3 comes in front of the circle. So I think I'd like to keep the marks in front of the axes, actually, because of that issue with the background grid. But another way we can solve that problem is on our X scale, we can call .nice. Now there's some space on the edge. What .nice does is it makes sure that the end point here, in this case it's 4, .nice makes sure that the ending points are nice numbers, meaning the scale domain itself ends on values that are suitable to use as tick marks, for example 4 and 8. Now I'm noticing these labels are a bit too close together, so we can tweak that by changing our axes. In axis bottom, we've got y is inner height plus 3. So if I change 3 to, say, 5, that separates our labels a bit more. But I don't like how it feels to have these hard-coded constants. I think I'll make this a prop called tick offset. And then we can introduce a new prop here called tick offset. And we can give it a default value of, let's say, 3 in case it's not passed in. But we can leverage this in our index.js by passing in that prop here, tick offset equals, let's say, 5. And let's do the same for our axis left. Axis left, we can pass in tick offset equals 5. And then in axis left.js, I'm going to also replace that -3, or 3 rather, with tick offset. And give it a similar treatment where tick offset is a new prop with a default value of 3. All right, now let's take a look. These 4s no longer overlap. Very good. I'm pretty happy with how this turned out. With this setup, it's quite easy to change what X and Y means. For example, we can change sepal to petal and change the label as well. And we instantly get a different view of the data. Because we're using React and D3 here and constructing everything from the ground up, we have full control over every detail. Where the details live exactly in the code is up to us as developers, and we can refactor as needed to make things more comfortable, to tweak and centralize in certain places. For example, let's say we want to change the radius of the circles. Right now, I believe that lives in this hard-coded value of 10 in our marks component. This is fine for a first pass, and even for tweaking, I can change it right here. But just for developer comfort, I'd like to make this into a prop. Let's call it circle radius. And then we add a new prop here, circle radius. Now in index.js, when we invoke our marks component, we can pass in circle radius equals, how about 7? There we have it. That's how you can customize the size of the circles. And when to refactor is really up to you. It's a stylistic choice. It's a delicate trade-off because the more you refactor and generalize things, the more difficult they become to modify later on. Like, for example, if we want to change this to be a line chart instead, we're going to need to get rid of that circle radius prop. So from this perspective right now, it makes sense. Oh yeah, let's add a prop for circle radius to our marks component. But later on, it might stand in the way of things. But that's why I love working with React and D3, because if this abstraction stands in the way, you can just bust it down. You're not limited like you are when you use something like Vega, where the implementation is hidden from you. You can't really modify it very easily without, forking Vega and getting into all the details. Just to wrap up here, I'm going to update the title to be stylized scatterplot, and I'll update the description to say a scatterplot of the iris dataset. And then I'll update this link to point to this gist here. I'll paste that here, and we're done. All right, that's all for making a scatter plot.